All right, let's just dive right into it. Welcome back to The Explainer. Today, we're taking a seriously fascinating journey. We're going to start by looking at the big picture, the macroscopic vulnerabilities of our massive energy grids, and then we're going to zoom all the way down to a very tangible, localized, do-it-yourself solution that could literally change how your house operates. We're talking about the rise of the prosumer and how you can actually build households' energy resilience.
Now, I want you to think about this for a second. What actually happens when the grid goes down for good? It's kind of a scary thought, right? We're just so used to flipping a switch and boom, the lights come on. But the real-world stakes of relying entirely on centralized power grids are so much higher than most of us realize, at least until that switch suddenly stops working.
All right, Section 1, the fragile power grid. So our first source today looks at a pretty stark reality over in Ukraine. The authors analyzed how massive damage to their infrastructure has led to these constant rolling outages for power, gas, and water. This extreme situation is honestly a powerful case study. It totally exposes the inherent fragility of a traditional centralized power supply when it faces a severe external shock. Basically, when the center falls, the edges just go dark. And the fallout? It's a huge domino effect. When the power finally clicks back on, you get these massive network overloads. That puts premature wear on the whole system, which, you guessed it, ends up jacking up utility tariffs for absolutely everybody. But the hit to your wallet isn't just about higher bills. The researchers looked at the real everyday costs: damaged equipment from crazy voltage spikes, spoiled food from defrosted fridges, and lost income when remote workers just suddenly lose their internet. The true cost of disconnection is incredibly high.
Moving on to Section 2, the rise of the prosumer.
Now, if you take nothing else away today, remember this word, prosumerism. It's exactly what it sounds like. We're talking about a model where households stop being just passive consumers waiting at the end of a transmission line. Instead, they actively generate power independently for their own needs. It's a massive shift from passive reliance to active autonomous resilience.
Which brings us to Section 3, 7 household energy strategies.
Okay, let's break down this table. You can really see how these 7 different strategies balance out risk and reward. Groups 2 through 4, they rely on traditional backups like batteries or diesel generators. Sure, you get short-term power, but you also get some serious drawbacks like noisy emissions and a ton of extra grid strain. Groups 5 and 6 use grid-connected renewables, which, believe it or not, actually fail during a blackout because they physically need the grid to operate. But Group 7, that's the ultimate prosumer setup right there. Autonomous solar or wind paired with battery storage. You get full short and long-term power, though you are at the mercy of the weather and limited by your battery size. But look, the researchers make a really good point here. Choosing your strategy isn't just about running to the hardware store and buying the shiniest new generator. It's actually a giant mathematical balancing act. You've got to weigh your everyday running costs, heating the house, running the stove, keeping the lights on, and balance those bills against the savings you get from generating your own energy, or maybe even the income from selling your extra power back to the grid.
Let's make this super concrete. Section 4, the solar window prototype.
Check this out. This is a totally standard double-glazed door in an Athens apartment, but it's been retrofitted with 4 50-watt flexible photovoltaic or PV panels. And if you look at the incredibly simple wiring setup, those super lightweight panels feed directly into a compact, portable power station. This right here, this is Group 7 from our table earlier. Autonomous solar with a battery completely brought to life right in a living room. So how does it actually work? Let's walk through this DIY microgrid, because honestly, it is shockingly accessible. First off, those flexible semi-transparent panels, they are literally just stuck to the door frames with double-sided tape. I mean, no heavy construction at all. Second, those panels soak up that intense Mediterranean sun, converting up to 200 watts of power. Third, the power just flows through some basic cables straight into a 504 watt-hour lithium iron phosphate battery station. And finally, you use that battery to power everyday stuff: smartphones, tablets, even a small microwave. The total cost for the whole shebang? Roughly 300 euros. Crazy, right? Now, this chart is basically the heartbeat of the whole prosumer setup over a 10-day stretch. That red line is the battery's state of charge, and the green line is what the household is actually using. Just watch how they dance together. During the day, the red line climbs as the battery stashes away that surplus solar energy. Then, in the evening, when the sun drops and everyone's home using gadgets, those big green spikes, the battery seamlessly discharges to meet the demand. It perfectly prevents the daytime solar power from being wasted and replaces the really expensive grid electricity at night. And that leads us to Section 5, savings and thermal comfort.
We so often ignore the passive elements of our homes. Because these panels were mounted right on the glass doors, they pulled off a really neat secondary trick. They acted as a physical solar shade. They actively blocked intense radiant heat from ever entering the living room in the first place.
Just look at the temperature gap during the 10-day experiment. The yellow line is the outdoor heat, right? Peaking like crazy in the middle of the day. But that purple line is the indoor temperature right behind those shaded doors. Notice how the purple line just consistently stays below that yellow peak? The shading effect is absolutely undeniable. To put a number on it, the researchers measured a solid 1 to 2 degrees Celsius drop indoors during those blazing afternoon hours. Now, I know 1 or 2 degrees might not sound like a huge deal, but in a hot Mediterranean climate, that is a game changer. It means you're running your air conditioning way less often, which saves a tremendous amount of energy. And get this, the battery system hit a massive 95% capacity factor. Basically, that means the setup was insanely efficient at soaking up almost all the available solar hours without overcharging or letting it go to waste. It was just perfectly sized to handle the 200 watts coming from those door panels. So let's talk euros. What's the bottom line payoff for a 300 euro setup? Well, in just 10 days, it generated 11 kilowatt hours. Project that out for the whole year, and you're looking at about 410 kilowatt hours. By swapping out expensive grid power for this simple DIY hack, the household would save roughly 90 euros every single year. So we're talking about a system that literally pays for itself in under 4 years, all while giving you backup power during a blackout.
Wrapping up the experiment, the researchers kind of hit the nail on the head here. They noted that these integrated panels significantly cut down on solar heat gain, while at the exact same time generating enough electricity to power daily low-draw gadgets. It really is the perfect marriage of passive architectural shading and active, energy-saving microgrids.
So we've seen just how fragile our centralized grids can be, right? But we've also seen how completely doable and economically smart becoming a prosumer really is, even if it just means taping some panels to a glass door. Which leaves me with one final question for you. Your windows let the sun in every single day. Isn't it time they put it to work? Thanks so much for tuning in to this explainer. I really hope this got you looking at the windows in your own house just a little differently.